Welcome to this video tutorial on performing PM on the Covidian ForceTriad using the Rigel Uni-Therm ESU analyzer. Your video instructor is James Knight. James is the owner of Biomedical Engineering Services and Training, BEST. He is also employed as a clinical engineer in a San Francisco Bay Area Level 1 Trauma Center. He currently serves as president of the CMIA Bay Area chapter, certified by the ICC as a CBET in 1997, and provides training in the areas of ESU testing, endoscopic video testing, video integration hybrid, OR troubleshooting, and intra-aortic balloon pump testing. He has spent 25 years testing and repairing medical equipment, primarily in the peri-operative arena. This video provides content on specific aspects of a preventive maintenance procedure for the ForceTriad, including REM, HF leakage, and power output. It is an alternative approach to use of external current transformers, precision power resistors, and meters. Other steps not included in this guide, but outlined in the Covidian Service Manual, complete a full PM. For future review of specific sections of this tutorial, return to this portion of the video, refer to the topic list, and use the slider in your video player to fast forward to the appropriate section.
Hello, my name is James Knight. I'm a biomed here in the United States. I'm going to demonstrate to you today how to perform a PM on the Covidian Triad using the Rigel Uni-Therm ESU analyzer. So today the Rigel Uni-Therm is being used and to perform our ESU PMs. There are four basic functions. You can press the menu key, which will bring up a selection of different tests, and also ways that you can download data once you perform those tests. The next key is the REM key. That's for testing the continual quality monitoring of the ESU. You can also do a wide variety of RF leakage tests and power tests. By the way, these are all soft keys, and depending on what program you've selected, they will show different variables you can select. Next, we have the start and stop button and the trim button. This trim function, you press in and you turn, and you can do a variety of functions. It functions like an encoder that turns you to go up and down. Next is where you plug in your REM cable when you're wanting to check the continual quality monitoring of your REM circuit. And then the next two plugs are where you plug in a foot switch if you wanted to automatically control your ESU analyzer. They're coded yellow for cut and blue for coad. This is the side panel of the Rigel Uni-Therm. It is a very handy way to make all your connections in a very safe manner. You're never exposed to any electrical current or voltage. I'm going to demonstrate you the standard way of just measuring RF output. You're building a circuit here. The red plug is coming from your output of your ESU analyzer. The red rectangle with an arrow is a variable resistor that you program, and you can go anywhere from 5 ohms all the way up to 5,115 ohms. This jumper just builds the circuit. So you go across here, and this connector right here is going to your REM circuit. So this is your neutral or dispersive. If you want to look at it with your oscilloscope, you can also plug in there to monitor this, this loop here. So this is set up to do your basic RF output measurements. Each measurement that you perform with the Rigel Uni-Therm actually has a diagram that comes up on the screen and shows you exactly what to do, whether you're doing an HF leakage or an HF power. So now we'll begin demonstrating how to perform the PM of the Covidian Triad ESU with the Rigel Uni-Therm ESU analyzer. Power both devices up, and this is how it comes up. And you'll press on the far right screen the wrench icon. And then over here on the far left screen is the main menu. You press the service, and then you'll enter 423213. 423213. You press the check, and now you enter diagnostics and then debug mode. Debug mode is now going to allow you to choose all of the different output functions. This is you'll now work from this screen for every single test we'll perform from here. This is where you'll set the output level. This button is where you'll turn the ESU on and off. The mode selection is where you select all the different modes that you have to test. We'll start at the bipolar low. Port selection is where there is a monopolar port 1 and a 2 and a bipolar and a Ligasure 1 and 2. Since we're going to do bipolar, we're going to select bipolar port, and we always keep it on closed loop. So that's how we do it. So now that we've set the ForceTriad up into the debug mode, we're ready to come over to the Uni-Therm and do a few things to get us ready to record a full auto sequence triad PM sequence. So we'll press the menu button, and there we'll go into auto mode. And in auto mode, we'll press the large trim button, and we'll enter in some type of reference that you want to do so you can come back and pull up this record later. I'm going to put in the hospital's initials, the hospital control number, and then what type of unit this is. And I type that all in, and I press the green button, and I turn the trim knob down, and this is highlighted red, and then I bring it down to the test I want to do, which is bipolar low, and I select that. Now I'm going to press next. And again, these instructions are there for you in case you've never done the test before. They're there. We're not going to waste our time. It says set the level of 10, and you can see that we've done that. We're ready to begin this test. And you just keep pressing pass once you've understood the instructions. Everything that you need to do is actually on the screen of the Uni-Therm. So this screen tells us that we're going to press the Start RF button to generate the RF energy. This is the pre-programmed sequences. Notice that they're all grayed out. The auto sequence already has it programmed that the bipolar load is 100 ohms, that the expected output is somewhere between 8 to 12 watts. You've set it for 10. This is all part of your sequence. So all you really need to do is press the Start button, and then you come down here and press the green Start button. And we also press the Start RF button. Now the triad is firing, you hear that, and you see the results appear right there. When the test is complete, you press Stop RF, and the only thing you really need to remember is from the screen is you press OK, and remember that there's 316. Because we want to enter in that 316 right there like this, and then press pass. And now everything else remains the same. You're just going to come over here to the up arrow button and move that to 30. And then we come back, and we'll do this over and over again for all the different output combinations that the triad wants PM. So again, we press Start here, the green Start button, and the Start RF. We begin to fire, and I still haven't pressed. There you go. And there's our 30 watts. It's actually just 29. So we stop the RF, and remember we record 538. We press the trim button in to enter our data, 538. That is within the specs, so we press pass. Now it tells us to select 95. Go back here. And so essentially, all you really have to do once you've set up the test is just press the Start button and adjust the level to the 3 different levels. So as soon as you've selected, you've got it on 95, you press pass. This again tells you how you've got it set up. Press this start button, the green start button, and the start RF button. You hear the device firing in the background, and you see the results showing up there. As soon as you get the test OK, you can press stop RF, and you turn off the triad from firing, and you remember to record 979. And so you press the large trim bob, and you press enter in 979, and you notice that that is a passing number, so you press pass, and you've completed the triad bipolar low mode output test. So each time we successfully complete a test, it's going to tell us that we're going to pass. And we just completed the bipolar low, so this time, notice that this area is highlighted in red. We push it there, and we're going to select the next one, which is bipolar standard. I guess we could do bipolar macro, it doesn't matter. There's all these different tests that they want you to do. So you press next, and again it tells you what to do, but we're already in that mode. It tells you to set up the bipolar macro mode. And so how do we do that? Well, we just come back over to mode selection, press there and now we're going to go to bipolar macro. And I know just from memory that the screen will tell you to do this, to go to 10. We're not going to change anything else at all. We still are taking the outputs from the bipolar port. We're still going to press the start RF button when we need to deliver the energy. And the Uni-Therm, just in case this is your first time around, it'll tell you what page of the manual you need to go to, how to connect the cables, all those things. But once you've done a couple of these tests, it'll just become very easy for you to know to go on. So you press pass once you're comfortable with this. We've turned the mode select to bipolar macro cut. We've selected all these instructions, so we keep pressing pass. Again, it tells us to press the green start button. So we're ready. This time I'll show you the diagram. This is what the side panel of the Uni-Therm looks like. The BP cut is there's a red cable coming out of the left-hand side and a black cable coming out of the right-hand side. The black cable goes to the far right white port. The far left red port is where you connect the red cable. This is just completing a circuit with 100 ohms resistance, and everything else, the Uni-Therm does the work for you. So we're going to press, you have to press start twice. I just want to make sure, are you ready? This is going to deliver energy. And then you come over here and press start RF, and you hear the triad is firing. You see the Uni-Therm measuring current right there. The test is complete because it says OK. We stop the RF. We remember to record 317. That's an important number, and it's referred to in your manual. So we're going to press OK, and we're going to enter in by pressing the large number, the large middle button, enter in 317, and press pass. You see there's the specs given to you by the manual. And now you'll just do this over and over again for all the different levels that the Triad PM wants you to do. So again, we go to the green up arrow, we tap this until we get to 30, and once, like it says, we've set the level to 30, all the other settings stay the same. It takes way longer to talk about this than to do it. I've done many of these Triad PMs, and I actually can get a Triad PM fully documented and done in 25 minutes. So we'll press the start button, the green start button, and the start RF button. Again, you'll hear the triad firing. You'll see the results appear on your screen. And when the test OK is, test complete and OK comes up there, you turn the start, you stop the RF, you press the green button, and record 542, or whatever your particular unit delivered. 542 is an important number to record because this is the actual output. Now we're going to set the level to 95. Again, pressing the green up arrow. So once you've done that, you just press pass. Again, you press start, start, and start. 1, 2, 3. You hear the triad, you see the results. As soon as you get a test OK, come up there, right there, you press stop RF. You remember 979, you press this. Press the middle button to highlight there. You put in 979, and it's very important. You're recording that. And you've completed the bipolar macro output test. So now we're going to do the next test. The next test is we push the large middle button. We're going to go to bipolar standard. We press the select button. We come over to the mode select. Well, let's not even do that. Let's just pay attention to what the instructions say. Instructions, again, help us set up the test. And then it says what manual to follow. And then it tells you right here, set the mode select to bipolar standard. So you bring your attention to the mode selection, and you press this button, the down button, and we select bipolar standard. Bipolar port stays the same, closed loop stays the same. We bring the level up to 10. And actually, level, start, and stop are the only real things we're going to do from here on out, because we've already completed 2 of the 3 bipolar tests, and nothing changes. So you've done those, you followed the instructions, so you press pass. This again gives you instructions on how to actually turn the machine on. Here we can show the diagram if you have never seen it and you want it, not really sure. But again, this diagram doesn't change for any bipolar output test. So now, this is all we do. We press start 3 times. Start here, the green start button, and the start RF on the triad. There's your results. As soon as you see test OK, test complete, you record 317 by saying OK, press the large middle button, go to your keyboard, enter 317, and press the pass. Now, again, just like in the previous tests, you bring the level up to 30. You're ready to go. Press start, press the green start button, press start RF, and give them fire. 539, test complete. Now it tells us to go to 95. 95 is the maximum power you can use here. Everything else stays the same, just like the screen tells you. Press start, press the green start, press start RF. The results appear on the screen. It says OK, test pass. Press stop RF. Press the green button and record 980 milliamps, or whatever your machine delivered. You do that by pressing in the large middle button, go to your keyboard, enter in that number, press pass, and now you've completed the bipolar standard output test. So we've completed the bipolar standard output test, and we've completed all 3 of the bipolar port tests. There's still another bipolar test to do, though it's not called bipolar, it's called Ligasure. The Ligasure device is a bipolar device. It's using vessel sealing, and it's a special patented technology that only the Covidian has. So we've completed that. We press pass, and we're going to come back again. We're highlighted red, so we press the middle knob, and we're going to turn this down till we come to the triad Ligasure test. We'll select that. We'll go to next. Again, the instructions are set up to tell you how to get there. It tells you what page in the manual you're supposed to be following. And the only thing new here is it's going to connect your two cables from an adapter on the side of the Uni-Therm to this blue adapter. We're going to show you what that blue adapter looks like by over here. So it tells us to select Ligasure test. So I always come down, you slide this down, and there's your Ligasure test. It's not Ligasure, it's Ligasure test. And now you get to select either Ligasure port 1 or 2. I do Ligasure port 1 on my for my HF outputs, and I select Ligasure port 2 for my HF leakages. That way I'm testing both of them. Now, there's this adapter where you connect your old style with your, this is the old style Ligasure in case you have the old Ligasure only device. I like using this device because I like using these shielded banana plugs. Shielded means that when they're not in use, there's no electrical contact capable. And when we test ESU devices, you have to be very careful because you're delivering, in one case, 5.5 amps. And that's quite a bit, and it will burn you. So I like using these shielded, and the shielded ones will not go into there, but they will plug in right into here. So again, this is a bipolar test, but it's the Ligasure device. So we're using this adapter, we're into port 1. Again, just to refresh, Ligasure test 1, port 1, and it says set the level to 1, not to 0.1, to 1. So we press the green arrow up, and now we're at 1. Now we've followed all those instructions. Once you complete these instructions, we ask you to press the pass button, and that'll take us to the next one. Again, this screen is the same as all the other HF output test screens, just telling you the sequence that you'll follow. Again, this now is telling you how it's programmed. The only thing different between the bipolar and the Ligasure is we've reduced it to 50 ohms. 50 ohms is what the manufacturer wants you to do this test at, and 50 ohms represents the common resistance across a vessel. So once we've done that, we can press show diagram, but the show diagram again is going to show you a bipolar cut HF power measurement diagram. So no changes there. So here we go again, 1, 2, 3. We press the start button, and then we press the green button, and then we press the RF on. So there's start, there's the green start, and here we press start RF. You hear the Ligasure firing, and you look at the measurements. As soon as test complete comes on, you press stop RF. You hear the tone, the low tone go away, and now it's important that you record the current. Always remember that 312 is what you want to know. The manufacturer, when you're performing this PM, is not interested in what the wattage was, it's interested in what the current was. So remember that 312, press the green OK button, press the large middle button, and enter from your keyboard 312. You notice it is within the range that the manufacturer specifies, so press pass. And now the only thing we're going to do for the next test is we're going to come back over here to the level and increase to 2.7. One thing to notice is you see in the Ligasure, we don't even care about wattage. This is amps. We're going to deliver 2.7 amps. Okay? So we press pass because we followed the on-screen instructions of the Uni-Therm. Again, it tells us how we've got this set up, and then it's 1, 2, 3. Press the start button here, press the green start button here, and press the start RF. You'll see the results come up on your Uni-Therm. 34 watts is not important, 823 watts is important. As soon as that OK comes up, you press the stop RF, and you press the green button, and press this middle button, and go to your keyboard and enter the number that your Uni-Therm displayed, which in this case was 823 milliamps. You notice that it is within the specs that Covidien provide, so you press pass, and now you're going to set the level to 5.5 amps. Again, another reason I really like to use the shielded banana plugs. 5.5 amps will burn your fingers. In fact, it'll leave a small little hole in your finger if you accidentally touch it. And that's not hypothetical. It's happened to me. So, we've done everything. We've told it that the screen has told us to do. So we press pass. Again, we press start. Green start button. Start the RF. RF begins to fire. And look, we are delivering into a 50 ohm load 1.673. That's quite a bit. So as soon as that OK comes on, we press the stop RF. We press the green OK. We press the middle button. And we enter in 1673 milliamps. That is right on target. We press pass. And you have completed the Ligasure test. So now we've completed the Ligasure test, and we're going to move on and we're going to begin testing the monopolar HF output tests. Again, every time you begin a new test, it always starts out with tap wrench icon on the far right screen, the main menu displays on the far left screen, select service, enter 423213, select diagnostics, select debug mode. This is just how you begin to arrive at the debug screen where you do all these tests. So once you've done that, you press pass. We're going to do monopolar coag spray. So we're just going to do a few things different. One of the things that we're going to do different is we're going to use the dispersive pad with the index pin cut off. And we're going to remove the black cable, and we're going to put in the neutral or dispersive cable right there. And this is our path. The red cable we'll use, we'll just plug it into a different spot on the triad to get the monopolar output. Again, it tells us what page in the manual if you want to follow along. So now we're going to go select the mode select monopolar spray. So we're over here in front of this mode selection. So we're going to press this button and we're going to look for monopolar spray, and we're going to set the level to 1 and the closed loop, but we have to, there's also the port selection has got to go to mono 1. So mono 1. So there we've done all those instructions. So where is mono 1? So we take the red banana shielded banana jack and we plug into the left hand side like that. Real simple. Again, just remember we're now going to, because this is monopolar, we're going to use the neutral or dispersive or REM or whatever you want to call this cable. It is actually the return current path. So now the setup is the same. We've done everything. We've pressed pass. We followed the instructions. Again, this instruction screen is the same for every HF test that we do. So press pass because we know it. What the test parameters are show up here. We press start here. We press start here. We press start RF, and we begin to fire. And we know it's right because there's our 1 watt. Important number is 50 milliamps. As soon as test complete comes on, we stop the RF on the triad. We press OK. We press the middle button and we enter 50. 50 is right in there. It's a good number. Now, the only thing we're going to do different for all of the next monopolar tests is we're going to change the level and we'll change the mode for the different modes. So we start at 1, we go to 30, and eventually we'll get to 200. But now we're at 30. Everything else stays the same, just like the screen says. As soon as you complete and follow all the instructions on the Uni-Therm screen, you press pass. You can do that very quickly if you want to. You press start, start, start. You fire away. There we see our results. As soon as we get the OK, I'm going to stop the RF. There it is. The important number to remember is not the watts, not the voltage, but the current. So we're going to record 252. Press the start button, press the middle button, enter in 252. It's right in the middle, passes the Covidian specs. Now it tells us we're going to have to go to 120 watts. 120 is the maximum capable in this mode. So that's all we do. We press pass because we followed those instructions. Press start, press start, press start. Wait for the test OK to come on, and we press the stop RF button, and we record the current. Current in this case was 503. Press the green start button for OK. Press the middle button, and we enter in. The result was 503. Again, it's well within the specs that Covidian has, so we press pass. We've completed the monopolar spray test. That's it. So we've completed the monopolar spray test. We press pass. We go on to the next monopolar test. We press the large middle button, turn the knob down once. That's the Monopolar Valleylab mode. Valleylab is very seldom used, but PM tells us to do it, so we're going to do it. Again, all of the instructions are just the same as the last test. Only thing that changes is what page in the manual. It's 615 to go to. It tells you to go to Valleylab mode. You do that by coming over here to the mode selection, and you turn the mono Valleylab mode right there. You set the port to 1 and the level to 10. So we're ready to do that. You followed all the instructions and press pass. Again, this instruction is the same for every HF test. Press the green start button, then the RF on, and then RF off, and record the MA delivered. So this is our pre-programmed load characteristics with Covidian specified in the PM. Again, it's 1, 2, 3. Press this start, the large green start, and start RF. As soon as the test complete light message comes on, we press stop RF, we come over here, and we look at that number, 189. We press the green button, push the middle one in, and we enter in 189, noting that it's well within spec. We press pass, and now all we do differently is we go up to the mid-range, which for Valleylab mode is 75. So once we complete, follow the instructions on the screen, we press pass. Again, this is the instructions that the manual gave us. Simple as 1, 2, 3. Press this start, press green start, press start RF. The Uni-Therm begins its analysis, displays its results. As soon as the test is complete, we press stop RF on the ForceTriad. We look at that, we remember 518, press the green start button, press the large middle button, and enter in the number 518. We press pass because it's within the specs. We come over here to the ForceTriad, and we set the level to the maximum of 200. Once we've done that, we press pass, indicating that we followed the instructions. Again, this is the setup for it. Simple as 1, 2, 3, start, start, start. Wait for the OK to come on. OK, Uni-Therm has completed its measurements, so we stop the ForceTriad output. We look at that number, 848. We press the green start, we press the large middle, and then we enter in the number 848. Since it is within the specifications, we press pass. You've completed the Triad Valleylab mode output test. So now we're going to measure the ForceTriad's pure monopolar cut output. We select it here. We press next. We follow the same instructions as they are. It tells us to go to page 615 this time because this is where the monopolar cut are. It tells us to select monopolar cut mode, port to 1, closed loop, level 10. So what we do is move down to monopolar cut, monopolar port 1. We follow those instructions, so we press pass. Again, same sequence as before. We're going to press the start button, this green start button, and the start RF. We're firing, we're delivering, we're going to record 190 milliamps. We stop that. Press the middle button, 190, pass. Now we set the level to 75. Everything else stays the same. Complete the instructions, press pass. Again, press this start, the green start, and the start RF. The Uni-Therm displays the energy delivered. As soon as the Uni-Therm tells you that the test is okay, you press stop RF on the ForceTriad. You remember 508, and you press the green start button, press the middle button, enter in 508. That is a passing value. Press pass. Now it tells you to enter in 300 watts. This is the most power that's delivered. Everything else stays the same. You press pass. Again, start, green start button, start RF on the ForceTriad. Watch the current delivered. It is 314 watts, 123 milliamps. We turn it off because it is complete. Record 1023. And we're done. So we've just completed the Triad monopolar cut test. So you've completed the monopolar spray HF output measurement test. You press pass. You now press the middle button. There's one test left to do. That's the fulgurate. And where will we find it? How do I have that labeled? It's not Ligasure. It's not. There it is. Triad coag fulgurate output test. We select it. We press next. Again, what do we do? In case you haven't noticed, this is how you always get into the debug mode. Instructions are there every time. So we press pass. The only thing that's different on this is it tells you to go to page 627 of the service manual to find out everything you can about the monopolar coag fulgurate power output test. I do this test in the monopolar 2 jack. It's just because I want to test both jacks. So we changed it up here. Press pass, and we're going to press pass. And so we come over here. What do? We're going to move this to monopolar 2. We're just checking a different output there. We're not doing monopolar spray anymore. We're doing monopolar fulgurate right there. We're not in monopolar 1 anymore. We're in monopolar 2. Monopolar 2. Monopolar 2. All right. So we've done everything we're supposed to. We're starting out at level 1, and everything else stays the same. The only thing we've done is we're going to check this jack to make sure that this jack is functional. Again, it's a monopolar test, so we don't change any of the connections on the side panel. All we do is continue to follow directions on the screen. This is what the specs in the manual say. We expect 1 watt. Then we press start, the green start, the start RF on the triad. It begins to fire a perfect 50. Test is complete. We stop it, press OK, middle button, enter in 50. That is a passing number. Now it tells us to go to 30. Everything else stays the same. We go up to 30. We press pass because we followed the instructions on the screen. This is the specs. We press start, green start, start RF on the triad. Triad fires. The Uni-Therm measures. Uni-Therm is complete. We press stop RF. We record 255. 255. That is passing. Press pass. Now we set the level to 120. We set the level to 120. All of those settings stay the same. Start RF on the triad. Triad fires. The Uni-Therm measures. 506. Test is complete. We enter 506. 506. It's a passing number. You've completed the fulgurate output test. So we've completed all of the bipolar, the ligasure, and the monopolar HF output measurements. Now we're going to begin a very important part of the test. That's HF leakage. HF leakage can cause both electrocution and burns to staff as well as patient. It's a very important test to do. It used to be very complicated, but it's a breeze using the Uni-Therm ESU analyzer. So we've completed that. Press the center button. We come down here and all of the leakage tests are in this one test. So we're going to press next. We're going to check the high frequency leakage current. We're going to follow 628 and 629, and the diagrams will be provided by the Uni-Therm. Press pass. Again, this is the same as the rest of the tests. HF leakage test on the monopolar cut mode. Testing with an open active electrode. Use caution. Please use caution. Okay, we're going to select the monopolar cut, and we're going to set to 300 watts. So, we change the we leave monopolar fulgurate, we go to monopolar cut. Try again. We're in monopolar cut. We're in monopolar port 2, and we press the green down arrow once, and it'll take us to 300. So now we're set up to do this. Except here's the important thing. We are measuring an open active electrode. Okay? That means we're going to disconnect the open active electrode. Why do we do this? Well, the folks who came up with this standard at IEC 606-2-2 want to simulate a malfunction in either the pencil or the instrument that's delivering, and they want to simulate a malfunction with the open electrode. The next test we do after this open active electrode, we'll use an open dispersive or neutral. So it's very important. This is why I really like to use this shielded banana pit plug. If you do not use this, make sure that that connector does not touch the ground or a conductive surface. Make sure it does not touch your fingers. So when we're all ready to do this, this sequence is the same. What's different now is the Uni-Therm is going to show you how to set this up. Okay? Now, how do we do this? We put jumpers here. We put jumpers here. plug in there. Press run, press start, we press start, and the unit is passing. As soon as we get an OK, we press stop, press OK. Now we're going to go on to the next test. The next test, as you see, is we're going to have the neutral is going to be disconnected and the active will be connected. And now it's not so dangerous because there's no current here. Again, this is just simulating a condition of the neutral pad being disconnected. So there's our test right there. We're going to run it. All we have to do is press the green start button in the start RF, and there. And there we're running it. It passes it. As soon as the pass comes on, we can stop the RF. The test is complete. Alright, now we're going to do bipolar HF leakage check. We're going to select bipolar macro, select bipolar port, and set to 95 watts. So, do mode selection on the triad. So, bipolar macro. You might wonder why we're doing bipolar macro. It delivers the most current. We're going to select the bipolar port. We're going to select maximum power, which is green down once. Now, we're going to go to the bipolar port. Bipolar port. We're going to disconnect. We're no longer doing the monopolar test. So the monopolar is disconnected. And before I actually even connect all these, we're going to follow the instructions on the screen. We've done this, so we're going to say pass, and when the unit's ready to test, you're going to press the green start, and then turn on the RF on for 8 seconds, and then off. So here is specs. Most importantly, here's the diagram. So I have almost completed this setup. The only thing I have left to add here is this third banana jack right here. Okay, the third connecting between the black and red. Keep the third one back here. So what are we doing right here? We're building a circuit. What kind of circuit are we building? We're building a circuit that has that 200 ohm resistor that the IEC 606-2-2 wants us to have. So the bipolar resistance comes, bipolar energy comes in there, goes across here, and then this jumper feeds it to here, and then down here we put the 200 ohm resistor in line. So this is very beneficial. 5 years ago, I used to have to put a big Dale 1% 200 ohm 100 watt resistor right here, and I'd have to connect with clips, and those clips weren't insulated, so the current, you could accidentally touch that, and when you were running this test, you could actually get burnt, just as they're trying to prevent a patient or a staff member from getting burned. You could get yourself hurt by doing this test. So now they've put the resistor on the inside. There's no possibility, there's no exposure to conductive parts when you're doing this test. So there's no worry. You can now do this test easily. So we're ready to do it. This is one of 3 different setups. A bipolar test is a little bit more complicated than a monopolar. So we're going to press run. We're going to press a start here, and we're going to press start on the RF. And the Uni-Therm does the rest for you. 44 milliamps, that is very standard. I've never seen a bipolar fail, but we still test it. So I press stop RF. Okay, now it tells us to go to the next. This is a different diagram. This diagram here is suggesting that what happens if one of the bipolar forcep or bipolar tool fails and it's the left tine fails. So we disconnect the left tine and we move, so we don't need this jumper. So we're connecting the right tine directly there, and we're suggesting an open, some kind of failure where the bipolar forcep fails. So that's this diagram that it shows you. And then once you set the test up correctly, you press run, press start, just like all the rest of them, and you come up with 33 milliamps, much lower than the 44. Test is going to pass. You press stop. Test is complete. Now you're going to do the next one. This next test is even trickier than the last one. What we're doing now is the very first bipolar test. The jumper was on the bottom. Now we're jumping it to the top. What we're doing now is the first test. Let's go back to this. This is where the first test looked. And so what this first test is simulating, IEC 606-2-2 wants to simulate is what happens if the right tine, the black lead, comes in contact to ground via the patient or some other 200 ohm load. So now for this last test, we just come up here. What happens if the left tine comes in contact? So that's the change that we make down here. You check it out. We've done that exactly. We press run. We press the green start and the start RF. And there you go. Notice that that's 51. Test is complete. We stop the RF. I just want to point out to you that the results were 44, 30, 51. 51 is half of what the monopolar is. This is very standard. You're going to have greater HF leakages where you have greater HF currents. So congratulations, you've done the bipolar. Now we're going to check the ligasure current. Ligasure current is, again, pretty simple. I've never seen it fail, but they ask you to do it. And so the only thing we're going to do here is we're going to change the mode select from bipolar macro. I'm going to go down to ligasure test. We're going to go to the greatest amount, which is 5.5 amps. We're going to select ligasure port 2. Why am I selecting 2? Because on the output tests, I measured 1. Now I'm just going to verify that this port also outputs. Again, I like to use this because this enables me to use the shielded. The shielded won't fit inside the ligasure like this. But when you use the adapter, and everyone has the adapter because you're using up your old product, if you completely switched over, if you still have the old standalone ligatures, and you're probably ordering old standalone ligasure handpieces, and this allows you to use your old standalone ligasure handpieces with your new ForceTriad. So, we've done everything that the instructions have told us. We've set it to ligasure test. We've gone to ligasure 2 port. We've set it to maximum current, which is 5.5 amps. And we've connected it to the right tine. Again, so this is the right tine. We're going to disconnect the left tine, and you'll see in the diagram shortly. Setup for this test takes a lot longer than actually running the test itself. These instructions are the same. This is what the manual tells you to do. And now, look at this, okay? So again, we're using the right tine, which is the black cable, very similar to the other test we did. So this red one is disconnected. This jumper's out. We're testing the right tine. So we're simulating a failure, an open of the left tine by doing this. Notice that the left tine is open. Okay? So that's what they want you to do. They want you to, all of these checks are trying to measure the worst case under some failure condition, just like when you perform an electrical safety test and you open the ground. So you press run, press the green start button, press start RF on the ForceTriad, and we measured 23 milliamps. Very low, always low, but the manual asks you to do the test, so we do the test. Now we move that. You could connect the red cable, or I just move this over to the, I move this to the left tine, and I keep everything else connected the same. It's still going to show me everything the same, but what I'm now checking is to see if a failure on the other side of the open. Press run, press start RF, even lower, very, very low leakage. Press OK. Now, one last thing to check. Patient HF leakage test. So this is described in the service manual. What is the patient HF leakage? Well, that's your patient dispersive pad. So they could call it dispersive pad. They could call it the REM pad. They could call it neutral. But in the book, they call it the patient HF leakage. So we press pass. Now we select mono blend. So we go to the mode selection. We go to mono blend, which is right there. Mono blend. Still didn't get it. Mono blend. We're going to be back to mono port 2. Not letting me. Mono port 2. And we're going to go to maximum current, which is 200. And so now that we've done all those things over here, we come back and double check. We're at mono blend. We're at mono port. Set to 200 watts. Press pass. Unit is ready to test. Again, press the start, the green, everything's the same. So now it's going to give us a diagram. What is this diagram? Okay, so we're taking, it's labeled neutral. You can call it neutral, you can call it dispersive, you can call it REM. And we're just checking what that leakage is from this with all other devices open. So again, neutral to here, press start RF. There we go. There's your result, 78 milliamps. As soon as you get test OK, you can press stop RF, press start for test complete, and you've now completed all of your HF leakage tests for the ForceTriad. So we're going to perform the REM check on the ForceTriad. There's nothing new on the ForceTriad REM check versus the ForceFX check. You still check the upper limit and the lower limit. Test actually stays the same. So you press, you use an REM cable with the index pin still present. You plug that in. There's your REM alarm. You press REM, and you go to the manual up. Then you press set limits. The upper limit is correct. You want to make sure it's there. The lower limit is actually 0. So there's 0. We set our limits. So now we're going to begin the test. How do we begin the test? Well, just like the manual says, just like the ForceFX, we go to 120. We start at 120. Actually pull this out and pull back in. By doing that, we're telling that the starting point resistance was 120 ohms, and we carefully dial this up. Somewhere, as you see the resistance incrementing, somewhere at 130, after 130 and before 130, you're going to hear the REM alarm. There it is. You press capture. You captured it at 130. Now we're going to do the manual down alarm. So we press this. There's our manual down. The service manual tells us to turn this down to 20. 20 is our starting point. You disconnect, get the alarm, you push it back in, it recognizes 20. And now somewhere between 5 ohms and 0 ohms, we should get an alarm. We're at 7, 6, 5, 4, at 4. So we capture that alarm, it shows up, here we've done it. We've completed our test for the REM. You can turn it back up and watch the REM go green. That's an important thing to note, is that you disconnect, plug it back in, it goes green. You hear the alarm when you go to 4, but you also note that the REM tab alarm lights red, like that. So you hear the alarm, you see the visual, you know it's working. There you have it, you've completed the REM check of your ForceTriad. So once you've completed all of your PMs, you're back down in the shop, you want to get all that data and download it to a thumb drive, and then take that thumb drive to your PC and get the data and attach that all the data to your PM records rather than manually enter it. So I take a USB stick and I put it in the USB port there, right there, and I go to the menu, and you see where it says data. You select data, and then we're gonna view data just so you can see it first before we even transfer it. And so there's quite a few tests that we've done here. We did the 28804, so we're going to go down to the 28804. And by the way, this is chronological, so there's my first 28804 test. Passed, but let's take a look at it. The very first test we did was a triad bipolar low, and here's your results. And so you actually can look at each one of those results. But you're not really that interested in viewing the data. You're actually wanting to transfer the data. So there's your test. You want to transfer this data. You press transfer. Are we using a USB connection? No. We're going to change that to USB memory stick. What are we exporting? We want to export the CSV, which stands for comma separated view variable file, the full file. So we press start, and this test is just downloaded.